Hello everyone, welcome back to the channel. Today I am going to show you how to build a smart diabetes predictor, using Python, machine learning and Streamlit. So this is what your output will be when we will be, executing this code. So this is an app, Streamlit, that we created, a smart diabetes predictor in Python, completely beginner friendly machine learning plus Streamlit tutorial. So here, this is a page you will be seeing here, for entering the health details. This is what we will be creating now, right? It will ask for the patient pregnancy, glucose level, blood pressure, skin thickness. You can change this as per the patient data, BMI, pedigree, function, age, likewise. And then if you click here on predict, it will give you the details regarding, the person is likely to have diabetics or not. So this is something that we will be creating in today's session. So by the end of this video, as I told you, you will have a fully working web app that predicts diabetes risk based on user health inputs like BMI, glucose level and age, and it shows the probabilities in real time. So let's dive in. So first here, let's talk about you know the tools that we will be using. So we'll be using the Python programming language. PyCharm, this is my favorite IDE for writing Python code. I like it because it provides autocomplete, error checking and easy project management. So libraries we will be using here Pandas, for data manipulation. NumPy we will be using for numerical computations. scikit-learn we will be like skit that we'll be using for machine learning, and Streamlit that we will be using here to create interactive web app. Make sure you have Python installed, and in PyCharm, creating a new project, then open the terminal. So this is what terminal look like, inside the PyCharm, and then you have to execute. Like first you need to install the library, so you have to type there pip install streamlit pandas scikit-learn streamlit numpy. So this will install the libraries that we need. So this is how it will look like when you install the libraries. For our project we are using the Pima Indians Diabetes Dataset. So this dataset contains health records of women with features like pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree, function, age, and the outcome column tells whether the person has diabetes or not. So we can load it directly from a URL using pandas like this, you know https. So this is the URL that I have used for the data set, and here we are writing, we are loading data pd is dot read csv. So this is pd dot read csv. It reads the csv from the URL, and names is equal to columns. It sets the column names. Data dot head, it prints the first 5 rows, so we can see what the data set looks like. So let's take a closer look here. So you can see the columns like glucose, BMI and age. So the outcome column is our target variable. In machine learning, x features is equals to all columns except outcome, and y target, that is outcome. So we will use these to train our model. Next, we need to split our data into training and testing sets. So this is important because we train our model on one part of the data and test it on unseen data to check accuracy. So here we are using from sklearn model dot selection import train test split, and then we have here x is equals to data dot drop labels, or the outcome. X is 1, y is equal to data outcome. X train, X test, Y train, Y test likewise. So test size here we are using 0.2, and a random state, it like 0.2 here means 20% of data is for testing, and random state 42, like it ensures the results are reproducible. So we have used here a random forest classifier like for training the model. So we have used from scikit-learn dot ensemble import random forest classifier, and then here we have used model is equals to random forest classifier and estimators 100, random state 42 likewise. So n underscore estimators is equals to 100, it means 100 trees, and dot fit here, it trains the model on the training data, so we can test how well it performs on our testing data. And then we have used here from scikit-learn dot metrics, so that is importing uh, accuracy score. So I'll show you where. So accuracy tells us like how often the model predicts correctly. And then saving the model, like to use the model later in a web app, we need to save it using Pickle, right? So importing Pickle here, pickle.dump. So this creates a file, diabetes model dot pkl, which basically contains the trained model. Later we can load it without a retraining. And then building the Streamlit app, that's the fun part, building an interactive web app with Streamlit. So opening a new Python file, diabetes underscore app dot py, so you can rename it from here, just click here and then you can rename this file. Importing the libraries and loading the saved model. So we have imported like Streamlit as st, Pickle, right, operating system, importing NumPy, and then we have used model is equals to pickle.load, that opens this files. And then we have created the input fields for health parameters, and then made the predictions, right, and then optional charts that we will be doing, and finally executing the app. So let's go line by line explaining, like here I'll be explaining you every concept, every function, and why we are using it in our Smart Diabetes Predictor project. So here Streamlit as st. So Streamlit library, it lets us create interactive web apps using Python, and st is a short alias for convenience. And then pandas as pd. So pandas is used for data manipulation and analysis. It works with tables, data frames, and PD is a common alias. And then NumPy as NP. So NumPy is used for numerical operations, arrays, and metrics. ML models require data in NumPy arrays. And then training, testing, splitting. So this this is a function from scikit-learn, to split data into training and testing sets. Then random forest classifier, so the machine learning algorithm that we use for classification. So random forest, it builds multiple decision trees to improve predictions. Then the accuracy score, here, that is used to check how accurate our model predictions are. And then finally the Pickle, it's used to save and load the trained model, so we don't retrain every time. And operating system, it's used to check the file existence, like if the trained model is already saved. Then data URL, URL like where the CSV data is hosted. So this is this particular form of URL. And columns, like list of column names, we use it because the CSV does not contain headers. So pregnancies, number of pregnancies, glucose, plasma glucose concentration, blood pressure, diastolic blood pressure, skin thickness, tricep mapping the skin fold thickness, insulin, that's 2 hour serum insulin, BMI, that's body mass index, diabetes pedigree function, that's risk function based on family history, and then age in years, then outcome, that's target variable. 0 is equals to no diabetes, 1 is equals to diabetes. And then we are using @st.cache data. So this is Streamlit decorator, to cache the data set. So it loads once, improving app speed. Then we are using pd.read underscore CSV. Data URL names is equals to column. So it reads the CSV from URL into the data frame with our column names. Then we are using data.head. That is basically it shows the first 5 rows for preview, and then st.sidebar, it puts the dataset preview in the sidebar of the web app. Then training or loading the model file is equals to diabetes underscore model.pkl. So this is the file name where the trained random forest model will be saved. Then we are using os.path.exist model file. So it checks if the model file already exists. And then x is equals to data.drop, outcome x is equals to 1. So features all columns except outcome. X is equals to 1 means column wise operation. Y is equals to data outcome, it means target variable, what we want to predict. Training, testing, and then splitting. Train, test, split. So it splits the data into training and testing sets like 80-20. Then we have random forest classifier. So it creates a random forest model with 100 decision trees. Then we have model.fit x train y train. So it trains the model on training data. Finally, we have pickle.dump. So model f. So it saves the trained model for future use. And then here we have the st.success, loading, it basically loads the model if already saved. So this logic ensures that we train the model only once, saving time for future runs. Then it's time for the user input. Okay, so st.title diabetes predictor. So st.title, it adds a main heading to the web app. st.number underscore input, so it creates an input box for the user to enter numbers. So parameters, we have label like minimum, maximum, and then default value. So these values will be used for prediction by the model. Then we have prediction logic here with the help of if condition. So if st.button predict, it means it adds a button. The code inside runs only when clicked. And np.array, it converts input values into a 2D NumPy array. Why? Because ML models expect 2D array samples features. Then model.predict input data, it predicts 0 or 1. Model.predict probe input data, it gives probability of class 1 having diabetes. st.error, it shows a red error box for high risk, and st.success, it shows a green success box for low risk. So this gives both prediction and probability in the app. Then there is optional dataset chat, st.subheader. So it adds a small heading, data outcome dot value counts. It counts how many zeros and ones exist. st.bar chart, it displays a bar chart showing the distribution of people with and without diabetes. So this helps to the users to visualize the data set trends. Now, how to execute this code? So in order to execute this code, you need to go on terminal again, and then right here Streamlit run, and then the name of your file. So here it is diabetes underscore app.py. So the app will open in a browser. You need to enter the values as I told. Once I click here, the app here will open in the browser like this, right? So like this. So and then you need to write the values as per your requirement. You can change it like as per the patient, and then you can click here on the predict. So here it will give you the results relating to that. So the key concept that we studied in this program, just to give you a recap, we studied about data loading and Pandas, like reading CSV, handling tabular data. We studied about feature and target selection, X features and Y target, data splitting, training versus testing, a random forest classifier, like ensembling ML algorithm for classification, dot fit for on training data, dot predict gives us class, and dot predict probe gives probability. And we used Pickle to save and load the trained model, and then we use Streamlit, UI, that's input, buttons, dynamic output and charts. Finally we use NumPy, proper shape for ML input. And that's it. Congratulations, you have successfully built your own smart diabetes predictor from scratch using Python, machine learning, and Streamlit. So we loaded and explored the dataset using Pandas. We split the data into training and testing. We trained random forest model to predict diabetes risk. We saved the trained model using Pickle for future use. We built an interactive web app with Streamlit where users can input their health parameters and get real-time predictions. And finally, we visualize the dataset with a bar chart to see distribution of outcomes. This project not only helps you to understand machine learning concepts but also show like how to deploy a practical ML model as a web application. So you can take this further by adding more ML models and comparing accuracy, creating graphs and insights for users, styling the app for more professional look. If you enjoyed this tutorial, don't forget to like, share and subscribe for more beginner friendly ML projects. And if you want to try this project yourself, comment below and tell me what creative features you add to your app. Thanks for watching, and I'll see you in the next video. Take care. Bye bye.